We've all been there. You buy a beautiful houseplant, promise to take care of it, and then life happens. A week goes by, you forget to water it, and suddenly it's a crispy, droopy mess. But what if you could build a tiny, automated bodyguard for your plants? A system that watches over them 24 hours a day and takes over the daily watering chores completely on its own. That's exactly what the Thinking Robot Smart Garden Kit does. Think of it like a living creature. It has a brain to make decisions, fingers to feel the environment, and muscle to do the heavy lifting. Before we build it, we have to establish one golden rule of safety. Electricity and water are a bad combination. You must keep the electronics perfectly dry in their enclosure, while the water pump stays submerged in its bucket. By keeping the wet and dry parts strictly separated, we can safely transform a handful of wires and chips into a reliable, worry-free garden guardian. Let's look at the parts on our workbench. The boss of this entire operation is a small microchip called the ESP8266. The ESP8266 acts as the brain of our robot. It processes all the incoming data and even has a built-in Wi-Fi antenna, which lets it communicate with the internet later on. Next, we add the DHT11 sensor. It is essentially the brain's thermometer, continuously measuring air temperature and humidity. Then we have the soil moisture sensors. These are the robot's fingers. We plant the gold prongs directly into the dirt so they can physically feel how dry the soil is. But the brain doesn't naturally understand physical feelings of wet or dry. We teach it through a process called sensor calibration. This diagram shows how we tune the sensor so bone-dry soil sends a digital 0 and wet soil sends a digital 1. Tuning these sensors is crucial. It is the exact mechanism that translates the physical state of the dirt into a simple yes or no language that the computer brain can actually read. A single microchip can efficiently monitor and protect an entire row of crops without needing a separate brain for every single pod. Now that the brain knows when to water, it needs to use its muscle, the mini water pump. But there is a problem. The ESP8266 microchip operates on very low voltage, making it physically too weak to power a heavy mechanical motor. To bridge this power gap, we use a relay module acting as an electric switch. Like a megaphone, the low-power brain whispers a weak signal to snap a gate closed, amplifying the command to unleash the high voltage needed to spin the heavy pump. Using relays to isolate sensitive, low-voltage computer chips from heavy, dangerous power loads is a core safety principle used in all modern industrial robotics. With everything connected, we can mount our sealed electronics box to the wall, drop the sensors into the soil, and place the pump securely in our water bucket. Now we let the system run. Hours pass, and the soil in one of the pots finally dries out. The sensor feels the change, the OR logic detects the yes signal, and the brain yells at the relay. Instantly, the muscle kicks in and the pump roars to life. Fresh water travels through the pipe, saving the plants. But our Garden Guardian has a bonus level. Because the ESP8266 has a Wi-Fi antenna, we can introduce IoT, or Internet of Things connectivity. The brain continuously beams the garden's moisture levels and the air temperature up to the cloud. When you look at this interface on your smartphone, you can check the exact health and hydration of your plants from anywhere in the world. You start out trying to save a few houseplants, but in the process, you learn how to handle power distribution, program logic gates, and send data to the cloud. You are using the exact same automation engineering that runs massive commercial greenhouses. If you want to build this system yourself and start your engineering journey, check out the link in the description to purchase the Thinking Robot Smart Garden Kit. Let's get building.